Hey guys, it's your pal Dave from Notes and Volts. You know the one. Here again for another live from the lab. Build things for your amusement, and if you're not careful, you just may learn something. So, welcome back. A couple of things. We have some new Twitch followers. I think I'm up to about 9 now, which is as close as you can get to double digits without being there. So yeah, this stream is really turning into a freight train of victory. All right, so some other new things. This is new. So I built this because I was tired of reaching for the keyboard like a freaking caveman every time I wanted to switch scenes. So now I can just push these buttons. Look at that. Pretty cool. All right, so that's pretty cool. And I'm probably going to do a stream on that one at some point. I just got to work out a few bugs, but it's almost ready to go. So yeah, welcome back. If you're not on Twitch already, like, why not? It's super fun. Join up, and then you can chat. When I do this, you can chat, and we can talk, and you can ask questions, and it can be kind of interactive, and which will make it more fun for me and for you. So join Twitch. And I'll also be posting these on YouTube. If they work out well, if they don't, I'll let them just disappear like it never even happened. Okay, so let's get to business here. So last time, if you were here, we built this little Midi controller, 6-button controller, and we kind of built it into a little keyboard that you could play melodies on and hook it up to a synth, and kind of a proof of concept thing. And before, we built this thing. So if you go to my site, notesandvolts.com, right up there, you can read all about how to build this and get the code and the whole bit. So, you know, this is cool and this is cool, but you know what's even better? Putting them together, making one giant button knobby goodness kind of thing that we can do lots of fun stuff with. So that's what we're going to do today. So we got this guy hooked up, and this time, if you remember last time, I had my DX100 Yamaha, which, you know, sounds questionable at best. So this time I'm trusting my handiwork to my Dave Smith Tetra, which will sound a lot more interesting and you know, not be so painful on the ears. So let's get started. So here's our thing here. So if you remember last time, we hooked these buttons into the digital inputs on the Arduino. So let me quickly draw what we are doing. So we built a MIDI input, which is this guy here, right? And a MIDI input, or sorry, MIDI output, excuse me, is very simple. So if I look at the pins on the back here, there's 5 pins. It's a 5-pin DIN jack. And we said the outer 2 pins we're not going to use, just these middle 3. So the pin on the left, looking here, is going to go through a 220 ohm resistor and then to positive 5 volts from the Arduino board. The middle pin is just going to go directly to ground, and the pin on the right is going to go through a 220 ohm resistor to the Arduino's TX pin, which is transmit pin. And the switches are going to simply, okay, so let's just do a switch. One side of the switch will go to ground. The other side of the switch will go to one of the Arduino pins. And I'm using, what am I using? I'm using basically pin 2 and all the way up to pin 7. Okay, so that's where my 6 switches are plugged in. And that's basically the whole circuit. That's pretty simple. The potentiometer circuit is pretty much the same thing. The MIDI out circuit is the exact same. The only difference is the way the potentiometers are connected. So basically, we're going into the analog pins with the potentiometers. So let me draw one. Here's a potentiometer. It has 3 pins. Okay. If I'm looking at it this way, the pin on the left is going to ground. The pin on the right is going to plus 5 volts. And the pin in the middle is going to one of the Arduino analog pins. All right, and there's 6 of them, so A0 to A5. Okay, so basically the way this works, as we turn the potentiometer, it's going to put out a voltage from somewhere between 0 and 5 volts. So depending on where I put it, it's going to vary between those two. And the Arduino is going to translate that into a value that we can then send to our synth. So that's basically it in a nutshell. So let's work on combining these two guys together. Let me just do a little housekeeping here. All right. Good. So first thing, we have a MIDI out on each board, but we don't need 2. We only need 1, right? So I'm going to use this one since it's a little more convenient. Just down. So let's take the TX line from the Arduino board, this wire, and we're going to move it to this guy. I'll do it nice and neat, the way your mother told you to. All right, so we can leave this plugged in. It's not going to hurt anything. It's not going to do anything. So this is going to be our active MIDI jack. Okay, so next we have to plug our potentiometer cables into the analog jacks on the Arduino. So I'm going to start to make it kind of easy for me to remember. I'm going to use this one is going to be A0 and then A1, 2, 3, 4, 5. All right, so just bear with me a sec while I do that. Thrill of plugging wires into things and watching someone do it. It was a topic of conversation. I watched the movie Orphan last night, and if you haven't seen it, that's a freaky movie. Like disturbing, strange. So if you like that kind of stuff, I suggest you go watch it because it's pretty damn cool. And yeah, probably set the adoption business back 10 years. All right, so there we go. Everything's plugged in. Let's do a quick check. Yep, everything looks good. The next thing we have to do, so remember we have the plus 5 volt line from the Arduino going to the positive, like the red rail on the board here, and that's powering everything there. And we have the ground GND line going to the blue rail right there. Okay, so we have to do the same to this, and we have to make sure the grounds are shared between the two. So let's take a green wire, and you know what? It's always a good idea to color code your wires, because if I see a red wire, even if I know I just plugged it into ground, I'm gonna, or sorry, if I know I plugged it into 5 volts, I'm gonna like plug it into ground just because it's green, and my brain will go, oh, that's a ground wire. So it's good to kind of develop a color system for yourself and stick with it, and it will help kind of eliminate some wiring mistakes you might do. So here we go. We're going to take this ground rail on this guy. So put it in, and we're going to connect it to this ground rail on this guy that all the pots are connected to. All right, so the grounds are now joined together. And now we're going to do the same with the positive rail. So to recap, the Arduino's powering these 2 rails, and I'm just jumping them to these 2 rails on the other board. All right, very important. And whenever you're hooking up electronics, you want the grounds to be common, because if they're not, you can get really strange issues, and it probably won't work too well. Okay, so that's basically it. And if all is good and just and right in the world, this should work. We'll see. We'll see. Okay, so let's, we got to program this now, right? And if you remember, I have that program I made up, which is supposed to make this very easy for you, because you don't have to get into all the details and the technical nonsense. You just have to change a couple of variables, and you know, tell it how many controls you have and what you want each control to do, and it should take care of it for you, right? In an ideal world, that's what will happen. So let's, yeah, we won't plug in our MIDI yet, because we'll keep this guy nice and safe. Nothing will happen to you. And let's program this. Okay, so, hey, I can just flip another channel. Look at that. Pretty fancy. Like I'm a pro or something. So here's our program, our Arduino program that we made last time. Now, if you remember, all we have to do is describe what we have. So we had 6 buttons before. So we still have 6 buttons, so that's good. The number of pots we have was 0. Now we have more. We have 6. So let's change that to 6. And that's that part done. Simple. Nice. Now we scroll down. Now, you remember, here was our buttons, right? Already described. So let's do the same with the pot. So the pot, I have some examples here, and you're free to use them. So basically, all you're doing is we'll uncomment them and make them active. So these 2 little hash marks are comment marks, and anything that follows them on that line will be ignored. You could write whatever you want after comment marks. So now that the comment marks are gone, these guys are now live. So we have the type pot. So if you're familiar with object-oriented programming, this is what we're doing. These are objects, and they're objects of the type pot. These objects are described in these helper programs right here, right? That you never have to look at unless you want to. So all the stuff you need is right at the top of this program. So we're saying these are pots, and each pot has its own number. PO1, PO2, PO3, very original. All right, but you could change it if you want, but what's the big deal? It's good, it's fine, it works. The next thing, pin number. These are the pins that each pot is connected to, A0, A1, A2, A3, A4, A5. The command parameter doesn't do anything right now. You could change this to any number between 0 and 255, and you can use it for your own program. Like, I don't have it doing anything right now, but in the future you could use it to do something different with the pot. Make it not MIDI, make it control the brightness of your LED or something. So you can program that in. So that's kind of like a little expansion, but for now we'll just leave it all at 0. The next thing is CC control, right? So this is the CC controller number that this pot will output, okay? And every synth has its own list of CC controller numbers that it responds to, and that's kind of up to the synth manufacturer how he wants to configure it. So there's certain ones that are common between most instruments, like CC1 is usually a modulation wheel on any keyboard, but there's other ones, depending on the functions of your synth, the manufacturer can like switch them up. So we're gonna have to go to the manual for this guy and actually look at how it's set up. All right, and let's go back here. Where are we? All right, there we go. Okay, and finally we have the MIDI channel, right? Now I have these all set on different channels for you know, an experiment's sake, but we want everything on channel 1. Okay, so because our synth is going to be on channel 1. So everything we want to send to that synth needs to be on the same channel. So if I had another synth hooked to this MIDI line, I could set it to channel 2, and this synth would ignore it, and the channel 2 synth would react. So you can get 16 MIDI channels in total on each cable. Okay, so we got 1 and 1, 0. That looks good. All right, the last thing we need to do is we have to add our pots to this array, and I kind of showed you how to do it in this comment. So add like this, ampersand sign, and then the name of the pot, and then comma, and then the same thing, ampersand sign, name of the second pot. So I could type that all in, but I don't feel like it. So let's just copy and paste it, because it's already done. What are you doing? Wrong bar. Okay, so put it there, paste. Beautiful, perfect. Okay, so let's do a quick verify of this code and make sure I didn't mess anything up. What's filing? Great. All right, perfect. It compiled, no error messages, very good. 6P01. Yeah, that looks good. Okay, so let's customize some stuff. So what I did here is I set up these to spell out I believe it's an A minor pentatonic scale. But let's double check that, and we'll kind of look at how we can verify that. So let's Google MIDI note numbers. All right, and you can see there's a bunch of handy charts here. Let's find a good one. This one looks good. So you can basically see there's the octave, so C, C sharp, D, blah, blah, blah. So we've got note 57, which is, where is it? A, right? 60, which should be C, yep. 62, which is D. 64 64, which is E, 67, which is G. And that's an A minor pentatonic scale. The coolest of all scales. And if you remember from last time, and if you didn't watch last time, I archived it on my YouTube channel. So go to Notes and Volts YouTube channel, and it's in my live stream collection, the one directly before this one. But basically what we did, if you remember in the buttons, we have this command parameter that does something. So if it's 0, it's a note, right? All these are notes. If it's 1, it's a CC message. So we actually set this last guy to be CC number 64. Now, you know, CC numbers aren't just potentiometers. They can also be buttons. So a CC number can be off and on. And the way that's accomplished is off is 0 and on is 127. All right, so we got our pentatonic scale, and CC number 64 is the sustain pedal on your keyboard. So if I hold that key down, it will make, you know, all the notes sustain into each other until I release it. Okay, so pretty good. Let's do a quick verify again, make sure I didn't mess anything up. Looks good. Success. Beautiful. All right, now let's go to our pot and some stuff with that. So we have to open up our Tetra manual, right? Because we love manuals at Notes and Volts. They are lots of fun. Don't like this Windows manual viewer. Okay, so let's go. Like, you know, we don't want all this easy stuff at the front, right? That's for noobs. We want to go right to the back, to the scary, technical, you know, boring, unfriendly stuff. That's all the good stuff. Keep going way to the back, and you should see something. Where could it be? Where it tells you how MIDI is used on this keyboard. Modulation is parameter list, no support, nope, nope, no warranty, nope. MIDI implementation, that sounds like a good thing. All right, so received controller messages, right? So this section here is kind of the more standard ones that most synths will respond to. So like we said, CC controller number 1 is a mod wheel, right? Controller 2 is breath controller all the way down. A couple of damper pedals, 64, right? Remember we said our button, MIDI CC 64, right? So that's what we want. Damper pedal is a sustain pedal, right? Okay, and yeah, these are common to most keyboards. Now, if we keep going down, hopefully there'll be other. Here we go. Beautiful. So these are the ones that are unique to this instrument. So to Dave Smith Tetra. So we can look through these. Here's the CC number. And this is what they do. So let's find some fun ones that we can put in. So we'll go back to our pots section, and we'll pick some good ones. So first one, let's do number 1, because remember that's the modulation control, and a lot of sounds do something with that. Pot number 2, let's go filter frequency. I love filters, and those are 2 controls I always like to have, is filter and resonance. So let's do 102 is filter frequency. The guy right next to it, let's do 103. 103. All right, and that's resonance. Those are fun. Those are really fun. Okay, let's see what else. So for the next pot, let's Eca Attack, right? So that's going to control how quickly the sound is going to play, right? Whether it's going to come on immediately as soon as you touch the key or if it's going to gradually fade in. So what number was that? VCA Attack 118. Cool. And what do we do for the rest? Yay, release. Want to do that? Let's try. What's a really? Let's do a sub osc level. Maybe we want to add like some lows to our sound on the fly. So let's add those two, and they'll be our last two knobs. 30, 31. I'm not sure what they're going to do for each sound, but I'm sure they do something. And that's what we're trying to do here, something. Hey, a quick check. Yep, everything's good. Channel 1. And everything's good. Let's do a quick verify. And all right, so let's program this into our thing. If I hit upload, this should work. It's like going to Vegas because you never know until you do it. So if everything's good, if you remember last time I had a little weird issue where the board wasn't responding, and it was a weird COM port conflict, and I had to change a bunch of stuff, and I eventually got it fixed. Because basically, you know, now that I'm streaming from my computer, I've got stuff plugged into every orifice on that computer, and it's not enjoying it. So I got a new USB card in the mail. It's coming from Amazon that hopefully is going to give me some new ports and clear up some of these things. But let's cross our fingers. Here we go. And hit upload and see what the heck happens. So it's compiling and uploading, and it's, oh, look at that, it's going. Oh my Lord. Fantastic. So that, I believe, worked. Crazy. Okay. So get the scope going. Now you notice in the bottom window here, I actually have an analog scope, right? Last time I had a digital scope, and that's you know, that was good. But the thing with digital scopes is they're not as good with low frequency analog lines. So like, you know, when you're trying to show a low frequency signal, the digital scope is not as good because they don't like low frequencies, whereas an analog scope doesn't really care. Like, it's always transmitting. So, you know, it can go as low as you want. Let me just check something and see if I'm still online. Excuse me for a second, guys. I want to make sure I'm still streaming. Let's see. 1 second here. 'Cause if I'm doing this for nothing, that would be a bummer. Let me see. Don't talk amongst yourselves. Okay, just give me a second here. Something's a little screwy with Twitch. I'm still new to this, so it's a little strange. It looks like I'm still there. Talking about. Right. Good. Yes. Sorry guys, I know this is riveting viewing, but it's going to get super exciting really quick. I hope. Okay, cool. Looks like we're online. Good, good. Good. So, okay, so let's continue. So we've just programmed our thing. We should be all up to speed. Let's plug in a MIDI cable. Great. And we'll see what's what. Okay, so let's go to you. Oh, cool. All right, so there's our pentatonic scale. And once again, if I hold the sustain key, it should all sustain together. Fun, cool. Okay, so that's part one. We got this guy working. So let's try our other part here, and hopefully yes. All right, so I think pot one was modulation. You can hear it's doing something. I don't know if I like that. It's doing something. All right, so our modulation works. So this guy was filter frequency, right? Cool. All right, very good. Nice. And this guy was third pot was filter resonance. That sounds like a resonating filter to me. Cool. What was the next one? The heck was it? Oh, attack. All right, so you see how when I turn it all the way down, the note comes on immediately. When I crank it up, the gradual fade, it gradually comes up. And that's attack time. That works. Awesome. Put that back to quick attack. These were sub oscillators. Oh yeah, something's happening. So I don't know if you can hear that, but there's definitely more low frequencies coming in. change the settings on my scope a bit to try to bring this more in line. And all right, pretty cool. So it looks like everything works. And you can do your own thing. Don't the camera, that's bad. So let's let's try this. Let's go full scope view and play with some stuff. You can see as I add that resonant pot, you can see the high frequency stuff kind of on the waveform, right? And as I kind of sweep it down, you can see that get a little lower, right? And as it gets higher, it gets more. Eventually, it just takes over the whole thing. Alright, pretty cool. There you go. So now we have more of a complete synth or controller. Take these subs out. Kind of cool. All right, there you go. So cool, works well. So that's potentiometers, buttons, potentiometers. How you can kind of look up different CC numbers, note numbers, how to figure out what's a cool thing to put on your synth. Yeah, neat. So the next thing, next time we'll look at adding more controls. So we've kind of maxed out the inputs on this little board. Like I could add some more buttons, right? I've got a few more. I could probably add another 4 buttons or so. But potentiometers, we're maxed out. We've used every available analog line. So the way we'll add more is by using something called a multiplexer, which is kind of like a chip that has many inputs and one output. And by changing a number, like a signal you send to the chip, you can connect any one of those outputs, or sorry, any one of the inputs to one output. So we would plug one output into one of our analog lines and just kind of scan through all the inputs, checking the different pots. And that way you could add many more controls, because you can get multiplexers with 16 lines. Which means technically you could get 16 pots into one analog pin, right? And you could do the same with digital. You could get 16 buttons into one analog pin. And if you think how many, or digital pin, and if you think how many digital pins we have, that's a ton. Now the only thing we have to think about is the more stuff we add, the longer it's going to take the Arduino to scan through all the controls, because what it's doing is it's kind of going checking all of these in a big loop, right? And the more it has to check, the longer it will take to, you know, get back to the first one. So eventually you may get so many that you may start missing button presses because it takes too long to come around. But it could actually take quite a few. Like I've hooked up quite a few to this code, and I never really had it have a problem, right? So I would say you're safe with at least 8 pots, and probably 16 buttons should be doable without much trouble. So there you go. I hope you had fun on this stream. Once again, like, you're not signed up for Twitch, why not? Just sign up and we can chat. And I'm not going to be here by myself like a dork, just talking to myself for however long it's been. And always visit notesandvolts.com, website, YouTube channel, Twitter. You know, follow me around. Come on, guys. You know. So this is Dave from Notes and Volts, and I hope you found this educational, and I will see you next time. So take care.